which storage is useful for the database management system. So that will analyze in this particular slide. So, so far we have studied the database management system at level of logical model. The logical model of database system is the correct level for the database user to focus on. The goal of the database system is to specify and facilitate access to data, right? As member of the development staff and a potential database administrator, we need to understand the physical level better than a typical user. Now it is saying that we have three level, right? One is the physical level, then we have the logical level, and then at last we have the view level. So all those three levels has some significance, and we know that the highest level of abstraction means highest level of hiding of information is there in the view level. The physical level, which is showing you the whole data and how your data is stored, means the data structure part and all. And then you have this logical level where you can define that how the structure of your table look like, means the schema and all, how the constraint are, how many columns are there, all those informations are there in the logical level. And in the view level, so we know that only one user is there who is in the view level, that is a name user who don't know anything about the database, and it will use the uh, interface for interacting to the database. Now here we'll see that how physically we can store the data. Not Actually, we're not going to see the how part. We are going to see the which particular storage will be useful for physical data storage. Okay, that answer we want. Which storage is useful for physical data storage, right? Now for that we'll see different type of storage we have. So storage media are classified by speed of access, cost per unit of data to buy the media, and by the medium reliability. Unfortunately, as the speed and cost goes up, the reliability goes down. Okay. So what is the meaning of that? We have different type of memory available, different type of storage memory available. Now, which particular storage will pick as the database storage? Now it says that for that we should have some criteria like speed of access, means how quickly we can access the data. Second, what is the cost of per unit of storage? Means if I want to store per unit of data, let's say 10 MB of data or 100 MB of data or 1 GB of data. So how much cost I have to pay? As well as we have the reliability, means how reliable is my storage is, means how far my data will be safe, right? So to take all those things in mind, we'll see different storage, and we'll see that how it will be useful for the database management system. So the first we'll start with the cache memory. You all know about the cache memory. Cache memory is nothing but the fastest memory available. Actually, we have registers also, which is inside the which should be inside the CPU, and that we are not considering because it is very smaller unit of storage, and it is the functionality of register is very much different. Now let's start with the cache memory. So cache memory is the fastest memory available. Um, fastest memory available after register. Okay. So, but here, whatever we are listing from that particular list, cache memory has the highest um, storage access, means we can access the data as quick as possible. So cache is the fastest and most costly for the storage, and it is most costly. The type of cache preferred to here is a type that is typically built into the CPU chip and is 256 KB, 512 KB, and 1 KB. So here we are talking about level 1 cache. Okay, sometime it is called register. So we have level 1 cache, level 2 cache, level 3 cache in that way. So level 1 cache always reside inside the CPU. Then we have level 2 cache, which is outside the CPU. Then we have level 3 cache, which is again outside the CPU. So, but the logic here is it want to say that the cache memory is the fastest memory available, but the costliest memory. Second, it doesn't have much capacity for storage. And the purpose of the cache memory is very different. It is going to store the temporary data. It is highly volatile because once we'll switch off the system, it cannot store any further data, right? So this is the disadvantage related to the cache memory. Cache is used by the operating system and has no application to database. So as I told you, it doesn't have any application related to the database. So in the database, what type of memory we required? We required the memory which should be reliable, which should have less cost, as well as the speed will be more. So all the thing, if I will look related to the memory, so it is not at all possible. Means everything we cannot achieve. We have to compromise some of the content, either reliability or cost or speed. Okay, let's talk about another memory, which is called main memory. Main memory is nothing but your RAM. Now, main memory is also a volatile memory, right? So once your computer is on, your main memory will be will be available, and once your memory will be, once your computer will be off, your it is of no use, right? Okay, so okay, we are in the main memory. So as we can understand from here that the main memory is nothing but the memory which is highly volatile. Second, it is costlier, right? It is costlier. Second, and we have the limited memory right now. Next thing is, can we use it for the database management system? And the answer is no, we cannot use it. The reason here is because it is a volatile memory. Once the power will be gone, your data will be lost. Now go to another type of memory, which is called flash memory. Okay, what is the meaning of flash memory? Flash memory is also called electrically erasable programmable read-only memory. And we know that what is the meaning of flash memory, right? So flash memory is nothing but your pen drive and all. So what happened in the pen drive? So pen drive has the capacity. Nowadays, we have seen that it has the capacity of 1 or 2 terabyte. But can we use it for the database management system? It is non-volatile memory, means whenever we give the power, it has the data. If we don't give the power, it doesn't have the data. It's okay. But the thing is that, can we use it for the database management system? The answer will be yes or will be no. Why yes, why no? If we will always connect the flash memory with the system, yes, we can use it for the database management system to store the data, because it is the data will be available even though the power is not there. But can we really use it for the database management system? The answer is maybe. If your flash memory is reliable, we can use it. If your flash memory is not reliable, means your pen drive is not reliable, will not use it. Okay, so answer is simple. Here it is saying that it has little or no application to the database management system. So the sentence was written when the capacity of the flash memory was very low. But nowadays, the capacity of flash memory is very high. As I told you, we can get 1 terabyte of 2 terabyte of flash memory or the pen drives. So in this case, in today's scenario, we can use it. We may use it. Okay. Now the next memory, which is, so we are in the increasing order of the capacity. Now the next one is the magnetic disk storage, which is your hard drive. So it is, we can say it is your secondary memory. Price is less. Storage capacity is high. It is non-volatile memory, means the data will be there for a longer period of time. What about accessibility is high. What about reliability is also very high. So the disk, which is your hard drive or magnetic disk, or nowadays we are also getting solid state drive or solid state disk, SSD, right? So all those are very much useful, or we can use this for the database management system storage, right? Next is your optical storage. Optical storage is nothing but your CD drive or DVD drive, right? So all those drives. So can we use it for the database management system? So the answer will be no, because it is very less reliable. Whenever this disk will get tampered, or maybe there is some scratch, so you may lose the data, right? That we cannot afford to lose the data. So reliability is in the priority whenever we choose any storage for the database management system. Next is the magnetic tape storage. So I think you all know what is the meaning of magnetic tape, right? Magnetic tape is nothing but this is the cheapest, slowest form of storage. And these magnetic tape we use in the previous days when the magnetic disk or SSD drive hasn't came into the existence. So we'll use magnetic tape to store the data, and it may have the capacity beyond the imagination, and we can make the storage available for the magnetic tape as much as possible. Is it reliable? Yes, it is very reliable. Is it cheaper? Yes, it is cheaper, means it has the lower cost. What about access time or accessibility? Very, very low. The accessibility is very, very low. Why it is low? Because you know what is a magnetic tape or magnetic storage, right? Like your cassettes and all. So we have to do a serial searching with that, right? And we have to go from one location to another location serially, right? It's a linear search we have to apply here. So once we'll apply the linear search, definitely it will become very slow. So why we are learning it? We are learning it because it is highly reliable, and today also many company used to store their historical data, their old data in magnetic tape because it is highly reliable. The data available into the magnetic tape will be available for a longer period of time. That's why. So the magnetic tape is very much useful for storing the historical data. It is not at all applicable for database management system where we require fast access, right? But here it cannot give you the fast access. So that's why magnetic tape cannot be used in the database management system. But yes, it can store a historical data. So these are all your storage, um, different storage, and which storage we can use it for the now for the database management system that we have just seen. Okay. Now let's talk about magnetic disk. So what is a magnetic disk? So you all know what is a magnetic disk, right? I don't have to is, give you the information about magnetic disk. So you all know magnetic disk, right? These are all your magnetic disk. In this magnetic disk, which you can see, we are using in our computer, we are using in our desktop, our laptop, right? And it is a very important storage for database management system. Okay. So it look like this. We have different disks available, and all those disks has two side, the upper and the lower side. In both the side, we can store the data, which is the up and the bottom. In both the side, we can store the data. So as you can see in this particular diagram, there is a read write head. So these are the read write head. This read write head has the linear motion, means it will go in that direction or that direction, means it is has the two motion, it will go up or down, means in that direction. And magnetic disk is there, it is attached with a spindle, and it will move or rotate in a circular motion. Okay, in that particular motion we have different disk available, magnetic disk available, and one portion of the disk is called platter. So we have two platter available to store the data. This is the one platter, another platter is in the downside of it. So it is called platter. Now the whole disk, one platter is divided into tracks. So as you can see, the circular, one circular uh, chunk of memory, or one circular chunk, as you can see, has some width, is called track. So track, you know, right? Track, we say where athlete used to run in the track, right? So we have the track available. So your platter is divided into different track. Now your track is divided into different sectors. So each track is divided into sectors. And this sector is the smallest size of storage. Means the sector size is, let's say, 512 MKB. So your data will be stored in the bunch of 512 KB. Getting it? Your data will be stored in the form of 512 KB. Means in the block of 512 KB. So it is called sector. So you have a track. Track is divided into sector. Your whole platter is divided into number of tracks. You have the read write heads, which has the motion. It will go the circular motion, and there is a it will go to the linear motion, and there is a the disk will go into the circular motion, so that the read write head can reach in each and every part of the disk by two motion. Okay, let's see some more different parts of the magnetic disk and try to understand it. So as I told you, these are all platters, and platter is connected with the spindle, and it will make a rotation, a circular motion. There is a read write head. Read write head is attached with the arm assembly, which will give it a linear motion. Each platter is divided into different tracks. So we have different tracks, and each track is divided into different sectors. And sector has some size, which is based on your it is a standard size, which is based on your manufacturing company, which will tell us that this will be the lowest bunch of data you can store. So that is sector. Okay, so I think you understood the how it looked like in the diagram, and this is how it looked like when we see it. Okay, okay, let's go to the PPT. The disk control interface, the computer system, and actual hardware of the disk drive. The controller accept high-level command to read write sector. The controller then convert the command into the necessary specific low-level commands. The controller will also attempt to protect the integrity of data by computing and using checksum of each sector, then attempt to read and write back. And the controller recalculates the checksum and makes several attempts to correctly read the data and get matching checksum. So what it want to say is, if in your hard drive there is a controller which will take care of the integrity of the data, whatever data you have stored, whether it is stored without any problem or not. If there is a problem, then the controller will decide that, and it will eliminate that particular sector which has the problem, and that is called bad sector. That is called bad sector. And we know that in that particular sector we are not going to use to store the data further. So that's why it is very much useful to divide the whole platter into tracks and whole track into sectors, so that the sector is the smallest unit of storage that we can use. Sector size could be range from 31 byte to 4096 byte, means around 4 how much it is, 4 KB. So from 31 byte to 4 KB it will go. 512 byte being the most common. So 512 byte will be the common size of the sector. For different manufacturer, they will use it. Now there are some different concept related to this magnetic disk, and the concept is this. The first is the seek time. Okay, so seek time is nothing but the time. Seek time is nothing but the time to reposition the head. That is read write head, to reposition that particular head, and increases with the distance that the head must move. Seek time can range from 2 to 30 milliseconds. Average seek time is the average of all seek time and is normally one third of worst case seek time. Now, what is the seek time? Seek time is nothing but the time it will take, the read write head will take to reach to the proper position, to read the data as well as to write the data. That is called read seek time. Rotation latency time is the time for which the head is over the correct track until the data rotates around and it's under the head and can be read. When the rotation is 120 rotation per second, the rotation time is 8.35 millisecond. The normal average rotation latency is one half of the rotation time. Now, what it want to say is how much time a track is taking to rotate to reach to the normal position, so that the read write head can read the data from that time. Then there is a access time, the time from when the read or write request is issued to when the data transfer begins. So when we request for read or when we request for write, so how much time it will take to begin or to initiate the read or to initiate the write, that particular time duration is called access time. It is a sum of seek time and the latency time. Means how much time it has taken. Seek time is nothing but the time to reach read write head to the proper position. Latency time is nothing but the delay, how much delay it has been taken. Data transfer rate is the rate at which data can be retrieved from the disk and sent to the controller. This will be measured as a megabyte per second. So Mbps, we know that. Next is the mean time to failure is the number of hours or the average until the disk fail. So mean time of failure is the number in hour until your disk fail. So generally the range will be 30,000 to 8 lakhs hours. Okay, it means that 3.4 to 91 year. This is the average life of any magnetic disk.